Hello everyone, welcome to Math Spellbook. I'm your host Peter, and basically we're going to continue on where we left off yesterday. So let's get into it, shall we? Alright. Hopefully you guys are doing well today. It is Wednesday and you made it to the middle of the week, so congratulations to you all for making it to the middle of the week. Alright, so let's get into it, shall we? Alright. Gotta click my tablet here. There we go. Let's drag this up here. I'm trying to remember what we learned yesterday about this, so that way we don't have to go into many problems. So I wrote those. So when it's Hey Nstunky, how's it going? And also, if you guys are not familiar with Nstunky, he's also a streamer as well, so I'll give you a shout out, Nstunky. Oops. Didn't want to capitalize that. Okay. Did we get it? Yes, we got a shout out. Nice, nice. They mainly stream like some math content as well as some science content as well, so you know, just basically check them out. Just hanging in, finally making breakfast. Nice, nice. That's good. Let me click my tablet again because I always have to click it in order to like write into it. What do you plan to have for breakfast? So according to Mavort yesterday, we write the model like this, so we have to solve it. I guess we're just gonna have to use separate, like he basically said, use separation, so we're going to do that. Hopefully I'm doing this right. Okay, it's not touching the chat. Okay, because I know the chat is on the left side, so I don't want to like mess up everything. So Torricelli's law states that under certain ideal circumstances, fluid will leak out of a hole at the base of a container at a rate proportional to the square root of the height of the fluid's surface from the base. Yeah, we just showed that yesterday over here. Suppose that the cylindrical container is initially filled to the depth of 1 foot. If it takes 1 minute for 3/4 of the fluid to leak out, how long will it take for all the fluid to leak out? Okay, so we wrote this yesterday, so, well, mainly Mavort wrote this yesterday, so I'm just trying to follow what they were trying to teach me about this problem, so. Eggs and... Oh, okay. That sounds delicious. I actually just had like lunch not too long ago. I had to shovel some snow and then I did my workout and then I just ate lunch. So we are given T, C here. And we'll just make this, well, yeah, we'll do that. I was about to say, should I have done the U substitution? And I'm like, no, that probably would be more messy to deal with. Oops, I just forgot that, like, because I'm so used to my whiteboard, and whiteboard I have to actually click to move it up, but this one I don't have to. Okay, so now I'm just going to write this all out, because whenever it comes to integrating this, I always mess up. So we are given 1/2, then 1/2, yeah, and then since this is, so we flip it around, giving us this. Let me just make sure that that's all correct. That looks pretty good. So we'll just continue writing it over here. No need to like go lower. Write this. Alright, so make this by 2. And then we take the square. Trying to make sure I did every step right. Okay, so now we have to figure out what C is. So we have 4/4. Cross those out, and then we're left with 3. And then do this plus. Actually, I should just write this out because I'm so used with numbers, like. So let's just do it like this, just to make it easier on the eyes. So then that goes there, so it's like plus T of C, then plus C squared. And then we have 3 here. Rewrite it like this. Oh yeah, we know the time. I forgot about that. So now we can just put the time parameter in. So I guess they want to know the rate per minute, so I know like naturally I would put seconds, but I think like putting minutes should be okay. So C2, and then we'll do 3 minus 1, which leaves us with C squared plus 2C minus 3. No, not minus 3, minus 2. Minus 2. Then we'll just drag this down here. And I'll rewrite it on this side. Oh, no, I didn't want a circle. Plus 2c minus 2. Yeah, I don't think that's factorable. So we're gonna have to do c equals minus 2 plus or minus 2 squared. Well, actually, we can just write 4 in there. Don't have to make it more complicated than it already is. And then we have 1 in there, and then 2 beneath. And now we get 2 values. Luckily, we have our trusty calculator to help us out. So I'm guessing it's going to be the positive value. I mean, I know we get a negative value, but hold on. Divide that by 2, so C is 1.73. And so if you do 2 minus the square root of dot dot dot, and then divided by 2, it's negative 2.73. So these are the constants. Now the question is, which one? Because we need these to figure out what the time is for like it to actually reduce. I mean, we can try both of them and see. So, because we know it takes a minute for. So the original function we have. Let's take the mouse. Oh no, that's not what I wanted to do. Undo. No, that's not what I want. Let's do this. I didn't want to take those 2's, but we'll just erase these and just rewrite them. Okay. Nope. Very, very fidgety. Just want to move it up here. All right. So. So it could either be 0.73 or it might be negative 2.73. Hey, Penn Center. I will also give you a shout out, Penn Center. If you guys are not familiar with Penn Center, they are an awesome math streamer as well. They give awesome math lectures if you want to learn real analysis. today? Oh. I think I know what the issue might be. Let me just check. First, I'll give you your shout out, Penn Center. There you go. So if you guys want to learn real analysis or linear algebra, be sure to check Penn Center out. They were given awesome math lectures on their stream because they're just straight up awesome and skill at mathematics. I am not near their level yet. But what's the best part of your day so far, Penn Center? Okay, so where are we? Oh, yeah. Okay, so we get 2 C's. And we know the time for, like, let's see if we get 3 over 4. So we have 1 minute plus, let's try 173, and then square that and divide that by 4. Zach and I had fun linear algebra stream this morning. Explored the properties of determinants. Nice. I started talking about fixed points of maps. Oh, okay. That sounded intriguing. That sounds intriguing. Yeah. Hopefully, it was a really eye-opening discussion. Well, the value is pretty close to 4 1/4. Let's actually try negative 2.73, because that's also a possible value. Oh, they're both very close. Oh yeah, because of the square. Oh, okay. So it really doesn't matter at that point. That makes it even harder, though. Unless I'm doing something wrong. Sad I missed it. Yeah, same here. Whenever you guys do linear algebra, I always miss it, and I'm like, oh dang, I always miss your linear algebra lectures. Respect that 8 a.m. Pacific time is sometimes early for folks. Yeah, true. I mean, I'm on the East Coast, so practically it's already like, if it's 8 a.m. then that would mean it would probably be like around like 11 p.m. for me. But that's usually when I like start exercising, because I wake up mad late. So both of these don't really like, well, Well, time has to be positive, because this is the time parameters being added as its constant here. So I'm guessing that this might, the positive value must be C. That's my guess. Because time cannot be negative, so why would time be... Yeah, I think C is... Gotta think like a physicist here. Like, I don't mind the 2 values, it's just that I actually need to actually write the equation so I can get the value here. Okay. So now, we have to figure out the actual time parameter. So H will have to be 1. And... So now we're just gonna have to solve for T. Plus... Actually, I should have lifted in variable form. That probably might have been easier. But it's fine. It's fine. But at least the best part of your day was like streaming with Zach, right? Right, Penn Center. I bet you two are like make like the awesome teachers. I wonder, like, if it was Hogwarts, like, I wonder who would be the charms professor and who would be the defense against the dark arts teacher, right? There's always a lot of dad jokes. Oh, nice, nice. I mean, I know some people don't like dad jokes, but I like them. I think it's because I'm at that age where it's like, don't take things so seriously, kids. Okay, so let's just take the square root. Don't need to worry about the hassle. So 2, and then we have t like that. Well, actually, the height, we already know what the height is, so we can just erase that, actually, because it's supposed to be 1 foot. So it's just 2, and then we just so to get the time, we just minus. Yeah. But because in 1 minute it's supposed to be 3/4. Pen is done and he's a is appropriately chaotic. That's just a straight man in this relationship. Oh my gosh. Like, imagine Penn basically giving like a defense against the dark arts lesson. It's like, intriguing, isn't it? Would anyone venture a guess as to what is inside? It's like, that's a determinant, that is. Very good, Mr. Thomas. Oh, okay. Oh, okay, so it's 1 minute and 27 seconds? That sounds pretty much correct. But what happened if you actually put the -1? I'm actually curious about that now. Because if you had the -1 and then you just do that, the only thing is that you'll be adding to it. Yeah, so then it would be like 2 plus, and then you would have to subtract it. No, not subtract it. You would have to, because it would be negative, so you had to add it. Yeah, that wouldn't have made much sense, actually. Because then it would be 4 minutes and 73 seconds. Well, that would technically be 5 minutes. So I guess like 0.73 is like the correct one, I think. So I think we got it. So it's like 1 minute and 27 seconds. Oh, the Academy of Useless Ideas. Thank you for the raid. Welcome, guys. Welcome, raiders. Welcome, welcome, welcome. I am Matt Spellbook, aka Peter. You may call me Peter if you like. I basically just stream my own mathematical adventures here, as well as physics adventures, because I like both math and physics. And I realize my model is actually blocking my stuff. So I'll just disengage my model. Welcome, welcome, welcome. How is your stream, Academy? Welcome, raiders. Welcome, welcome, welcome. Join the mathematical adventures we're doing here. I have to I disengaged my model because it was blocking one of the values here, because I realized you guys weren't able to see it. So this is the answer I came up with. Welcome, Kagerex. How's it going? Just abusing the little power I have to raid people. No. But I appreciate you raiding into my channel. That's very, very kind of you. Very, very kind of you. And I'm also give you a shout out, Academy. So if you guys are not familiar with Academy of Useless Ideas, that's I actually have to say that is the most clever name, because I think the name was the thing that made me want to raid you the first time. So I was like, oh, I actually like this. So basically, if you guys are not familiar with the Academy of Useless Ideas, they are an awesome streamer that are basically just educating us on math. And, you know, like, despite the name, I would have to say that it's useful knowledge that you'll probably use creatively. So, let's give you a shout out. Okay, yeah, I think we got it. Okay. I'm not partial to differential equations. Hopefully that doesn't make me ordinary too. No, that's okay. Megalomorph? But, Academy, if you have to, like, rate and go, that's understandable, because I know streaming takes, like, a lot out of a person. So, like, if you need to go out and rest, that's perfectly fine, and I'll basically try to keep up the excitement for everybody that's from your stream. Remind me, like, not remind me, let me know if I'm mispronouncing your names, just to, because I want to make sure that you got, that I pronounce your names correctly. So, Kagerex sent a little emote, but Megalomorph, I don't know if you were making a joke or you haven't done partial equations, neither have I. So I'm basically just trying to learn as much knowledge as I can about partial differential equations. And actually, like, in this book, the book I'm working with, you were making a joke. Okay. Actually, like, for everyone that was in the raid, right? Are any of you guys graduate students, or you guys are currently university students, or you guys are working, like, you know, full-time at a job somewhere and you just love math, or you're actually using math, or like whatever science knowledge you have? A former grad student. Oh, okay. Did you get your PhD or your master's, Megalomorph? Okay, so I think that's the correct answer. If not, then we'll know. We'll probably know, because, like, for all those that came in, so I was working out this problem here. So according to this, we are so we're supposed to imply Torricelli's law, which says that a fluid will leak out of a hole at the base of a container at a rate proportional to the square root of the height of the fluid's surface from the base. So suppose that a cylindrical container is initially filled to the depth of 1 foot. If it takes 1 minute for 3/4 of the fluid to leak out, how long will it take it for all the fluid to come out? So, I mean, I think I did everything correctly, because I remember yesterday I was working on this problem, and one of the people in chat basically, like, helped guide me to get to the actual setup of the equation. So I was getting my PhD, but due to an illness, I dropped out of my thesis. 99. Oh, I'm sorry to hear that. I mean, like, the thing is that, like, how was it long ago that you had to, like, drop out, or was it, like, recent? And what were you working on for your thesis? I'm actually curious. 2011. Oh, I'm sorry to hear that. Well, read that, actually, technically. But, you know, like, sometimes life basically say, hey, like, you know, maybe it's time to step back a bit. You know, you can't control what happens sometimes. I mean, like, what are you doing now? Actually, Megalomorph, if you don't mind me asking. Because, I mean, doing a PhD is a lot of hard work. If you had to drop out for your health, like, you know, that's reasonable. So what's the next question here? The one thing I don't like about this PDF is that it doesn't have a it doesn't have a bookmark section where I can just click a page. Solve the following first order linear differential equations subjected to the given condition. Now, can I copy all this? That's the question. Hopefully I can, so that way I don't have to write everything. Okay, that's not too bad. Are some parts missing? Let me check here. Yeah, some parts are missing. Oh, thank you for the follow, Megalomorph. Thanks to you, we got 40 people. We got 40 followers. Yay. I love it when basically we can all, like, basically just, like, meet up. Meet up in our interests, like both math and physics. My thesis was a little bit of representation theory representing mathematical physics. Right now, I'm an online math tutor. Oh, okay. I see. I might actually have to do that too, like try to set up like be a mathematical tutor online. But I feel like with the amount of people that I've been meeting like on Twitch, like that are really good at like teaching math and knowing math, I feel like I'm probably not at the level of being able to teach tutor math. If you want, I can DM you a link to the paper. I was in the process of expanding. Yeah, because I'm actually interested in mathematical physics. Like, I'm not going for a PhD or anything. I just really am interested in the subject. That's why I'm, like, learning math and physics right now. Yeah, and also, like, the link to our Discord is, like, on top, above. So if you would like to join our Discord server, please join our Discord server. We do have a channel dedicated to mathematical physics. Although I haven't typed anything in it because of, I don't know enough knowledge to actually get to that point. Let's see. I think this one's supposed to be 0. So, done. Let's see. This is B. I'm going to. Oh, whoa. That is. I gotta bring these down. Okay, so I can copy some things, but not everything. So I think we should just like move these. So let's right here. Let's do that. Yeah, we're definitely gonna need more space. And I think it's also missing some things. Okay, so this is C. Wait, where's D? Oh, here we go. There's D. So we'll just put that down there. So then we can move E and F here. Wow, this is a really long one. I don't know what this is part of. What did I highlight? Oh, this is an initial condition. Oh, we have like GH. Okay, so that's why it's so long. Let's see. Where's H? So it's pi to 100. Let's see. 0. Maybe I have to zoom in to see X. Yeah, this is why I don't like copying problems from the book sometimes. Because I have to see like what is missing and what's not missing. So instead of doing that, I'm just gonna like, because I know I'm wasting a lot of time doing that. Invalid invite. Oh no, don't tell me I have to set that up again. Oh boy. So I'm just going to do that. Okay, I gotta fix that. Otherwise, that's gonna annoy the heck out of me. Alright, so invite people. Oh, who else followed? Oh, thank you, Surino, Hakenji. Never disable. Oh, is this you, Megalomorph? I got a Discord message that basically has a paper in it. Trek. Is that your Discord name? Yeah, that's you. Okay. Oh, I think you got in, because I see you in the Discord server. Okay, so I don't think I have to fix it then, because it seems that you got in. Okay, so that's good. You managed to get in. Okay, so now we can get... but thank you for the follow, Sudino. Really appreciate it. And if I'm mispronouncing your name, please let me know. I will feel bad if I mispronounce your name, because I did study Japanese, and your name kind of sounds close to, like, a Japanese name. I mean, at least to me, but I don't know if it's, like, another language. If it is, like, I apologize for making the assumption. Oh, this is... I don't like the way this looks. So I'll just pull this. And I think we'll just pull this over here. Okay, we'll just do this. And I think we'll just close this part. And we'll just have to do it one by one. Because the big part we care about is the writing. And I know I wasted so much time doing this. So let's just... No, don't do that. Okay, can I delete that? Yes, I can. And we'll delete... No, don't do that. Don't do that. Okay. No, I wanna... There we go. Okay. Alright, so let's get into it. So it says solve the following first order linear equations subject to the given condition. Hi, I saw PDE instant follow even though I know nothing about it. No, it's fine. It's fine, Sudino. Actually, like, I don't know if I asked you guys this. Like, what's the best part of your day so far? Everyone that was in Academy for Useless Knowledge's raid. It's Japanese. I was ginger ale. Nice. Nicola. Nicola Borbaki. Interesting name. You guys have interesting names, actually. I like that. For a... So we have y of x. So we're not on we're not on PDEs yet. So you know, we're basically working the basics of differentials right now, because I'm actually working on a book that basically says you don't really need differential equations, like, to know it, like take a course on it. The book is really, I guess, like, beginner friendly, because it says all you need is calculus. So I'm like, oh, okay. So I thought I would just try this book out. And I'm actually liking this book, because this book feels as if, like, it's very simple in its explanations, and it feels as if it's like, it's kind of like, you want to take partial differential equations, it's kind of like meant for me, because it's like, I feel as if, like, I want to learn, but I want to learn, like, the subjects, but at the same time, it's like, I don't know what part of the previous subjects I need to know to get to this point. And I love the books that basically say, oh, you just need a little bit of this, a little bit of that. You don't really need to know the whole entire curriculum, unless you really need it for a problem. Tesla and Nicholas. It's kind of funny. I'm having a class on computational ODEs, which... Oh, okay. Okay, interesting. Physical books. Yeah, I actually have the physical book with me. Okay, so we got, okay. So I think this is something we're familiar with. So, dy dx plus 2. Let's make this easier to see. Okay, so now, I think we know what we're going to do. We're going to do the integrating factor. But do we have to? Yeah, we'll do it, because it looks like it's in the right form for it. I actually love the integrating factor because that was like I think that was the first thing I learned in differential equations. Okay, so do you have any reference on matrix theory? I think ODEs, maybe PDEs, is all about matrices. No. I did take a course in linear algebra, though. So I do know a little bit about matrices, but not like, you know, like expert level. There's a lot of perspective on PDEs. To solve the basics, you can get by with some calculus and maybe some linear algebra for more advanced things. You want measure theory and functional analysis. Yeah, like I plan to study like some real analysis like pretty soon too. I wanted to learn PDEs because I want to be able to learn like the calculus of variations. So where was I? Oh yeah. So E, then times, and then we get EX times E2, making this E3, well, E3X, so putting those together, we get the product rule. Yeah, we get the product rule. I want to make sure that I double check so it's like, oh wait, there's something wrong here. I always like those scenes in movies and like shows where it's like the scientists like writing on the board. I always remember like I said this yesterday. I was watching I think it's a National Geographic's like I guess dramatization of Einstein's life. And like I always remember the scene when he was trying to figure out the equation for his field equations for general relativity, and he was trying to like figure them out before David Hilbert. I actually love that scene. I replay that scene all the time. It's like, this equation works for planetary orbits, and this one, yes, yeah, is a pull of the vase. I just love it when scientists like mumble with themselves when they look at equations. In grad school, I had functional analysis class taught by a PDE guy, and it was scary. Oh, dang. I hope it wasn't too intimidating. Well, then again, like, I haven't gone to grad level. Well, I don't know, like, grad level, like mathematics or physics for that matter. So, you know, like, I can't imagine, like, how scary it is to, like, face, like that type of intensity. So let's just write it all out. I could probably do it in my head, but I don't want to because I know I'm gonna screw up somewhere. So dx is du over 3. I just hate it when I don't have enough space. That's the thing that annoys me. I'm pretty sure every mathematician and every scientist feels the same way. It's like, oh, I need more paper. I need more paper. So 1 over 3, and then, oops, no, not F. Oops. My mic is like right by my head. Like I accidentally like bumped into it a little bit. Galois for sure. Half of the class failed. It was fairly intimidating. Oh, there was like a little bit more you guys typed. Yeah, because I heard in math, like when you're a graduate student in math, you have to memorize like a lot of theorems, and I'm like, dang, grad school they don't play around. And then we get e to the 3x, and then 2 here, and then we'll just get plus c. And then we have to divide this. So y is equal to... Technically it... I mean, I could take out the... Nah. Forget it. I'm not gonna do that. It'll be more work on my part. And if you guys see that I do a problem wrong, let me know. Oh, it's break time. I didn't realize that. Yeah, I think I have to actually move my OBS sounds to oh, it is in my music. What? I wonder why I didn't hear the bell. I usually hear the bell when it like sounds off. The most famous mathematician died before there was any recordings of them. For sure. Well, it's break time, guys, so like if you want to rest up, relax, like, you know, actually, like, I will take a look at your paper, Megalomorph. I probably will. I know I'm not gonna understand it, but I'm like curious on what it is. But I'm not gonna show it on my other monitor. Hopefully it doesn't pop on my other monitor. Okay, it does. Okay, so I'm just gonna drag it on my other monitor here. So let's see what we got. I bet ansatz for symmetric groups. Ooh. Let's view the PDF here. But thank you for sending me your paper, actually. This is the first time I've actually seen, like, well, actually, I should put my model up because we're not doing any math right now. Is this like a partial of your paper? Linear algebra is essential. Yeah, I agree. I'm actually trying to study back on linear algebra a little bit. Like, the thing that I'm lacking with linear algebra is, like, I know the basic, like, matrix operations and the basic, like, vector operations. I just haven't done, like, I've done linear transformations before, but I barely remember the techniques involved with those. And, I have to remember everything involving eigenvalues, eigenvectors, possibly eigenfunctions. Yeah, like a lot of stuff that I completely forgot. I think calculus should be skipped and do linear algebra instead for 3 semesters, just like calculus. I don't know about that. And if you guys are tuning into the stream for the first time and you love math and love physics, be sure to drop me a follow. That way I can keep making like more of these study streams for you guys. I just basically do study streams because, like, obviously I don't know that much when it involves like abstract mathematics and abstract like physics. I want to get to that level though, but I'm doing it on my own because I don't think I would be able to handle the stress of grad school. I'm adding in a bunch of context for the version that will be going to be my thesis. That was some research I did that I didn't really like, but none of the research projects cared for actual oh wait, hold on. None of the research projects I cared for actually worked out. Oh, I see. I mean, at least you've done to the point where you actually can do research. I mean, the thing of it is that like, I mean, it would be cool to like be able to like read paper, because you can access papers through how do you pronounce this? Arciviv? Like God's what a mood. Archive. Is that how you pronounce the website? Oh, okay. The X is so archive. Okay. I got it. That makes more sense. Yeah, like I mean, since we have access to like that to the archive.org, right? Like it would be cool if like you just research like heck and you basically were like, oh, I think I can write a paper, like, you know, like just studying on my own and all that stuff. I mean, obviously you still need like the training and stuff, but I think that's a really interesting like kind of project. It's like, you know, like how we had like backdoor inventors, like backyard inventors, we have like backyard theorists. But then again, some people will say they're conspiracy theorists. I don't know, I'm just making up speculation. Like, you know, for me it's like I like studying this stuff, but when I read these papers, like legit science, I want to be able to be literate enough so I can actually read this awesome stuff actually. Because like obviously, you know, like I like reading books on it, like, you know, about quantum mechanics, about general relativity, but at the same time it's like I haven't gotten to the nitty-gritty of like what it means to actually fully understand the like what I guess what grad students and what physics majors understand about it, you know, like the math, the problem solving, how it functions within an actual physical system, all that good stuff. High particle physics, high energy particles physics. Oh, interesting. No, not a reference to Euler. It's just the Greek letter that people use in math and physics. Oh, okay, I see. Well, I feel like every time when I stream, like I can learn a lot from you guys actually. Actually, Nicola, are you a graduate student or are you actually working like in STEM? Or you're just working and you just love math and physics for the heck of it? I mean, for the sake of it, actually. Because I'm actually a hobbyist. I guess I view myself as more of a hobbyist. Me too, but it's normal, I guess. I like going to seminars where I only understand the first 5 minutes. Yeah, because like I think when learning math and physics, if you're humble with yourself and compassionate to yourself, you acknowledge that you don't know anything. In fact, you acknowledge the fact that you're probably like one of the stupidest people in the room, which is not a bad thing because it's like it shows that you have a lot to learn. And like if you do have the humility to say, hey, I don't know anything, and if you don't know anything, that means you have a lot to like look forward to if you like learning. Some people don't like it. They don't like that feeling where it feels like they don't know nothing. Here's the thing. Oh, dang. Yeah, it's Euler. Yeah, sorry. Like, for some reason when I see it, like, I don't know why I keep thinking of Euler, like the word Euler. I don't know why it's like that popped into my head. Yeah, you're right. It's Euler. Yeah. Ugh, my tongue was like tongue-tied. Because Euclid. Oh, okay. Yeah. That's probably it. Yeah. I meant X as in Euler characteristic, but I guess that's too much of a fantasy. Yeah. Because actually, like, what inspired me to get into math and physics is because obviously I've read like books that are like layman's terms. Like, you guys can like shake your head at me all you want, like when I say this, but I first read like Michio Kaku's books, and then I started learning a lot more about like other authors, like you know, Brian Greene and Sean Carroll, and like other science writers, and then I basically just like started trying to get into textbooks, and I started to learn like the basics of like, you know, other like basically the classical stuff, like classic mechanics and all that stuff. And I'm trying to like mature myself to actually like solving problems, even though like I do less of them. And I think with the streams, I basically just do problems because it feels as if I'm doing it with a community rather than I'm just doing it in the solitude of my own room. So, you know. But that's basically how I feel about it. It's like, I know I'm never gonna be like a grad student or like someone that's like a professor of the subject, because I don't think I would be able to like reach up to that level. But at the same time, like, to be able to like do content revolving around it, I think that's the best part. It's just being able to enjoy having a hobby, but like basically having that hobby reach others so that they feel as if that they can unite within the love of the subjects. And I think that's the most empowering thing, especially like start with type theory. What's type theory? Actually, I've never heard of that one. And if you guys are just tuning in for the first time, drop a follow for the channel if you love math and physics, so that way we can form like our own little research institute. Instunky, the laugh emoji, nice. Well, like, I don't know what emote that is. Like, I know it's supposed to be like a chuckle emote for like Twitch, like the staple chuckle emote. Yeah, honestly, like, I'm surprised that when I started streaming, like, a majority of you guys in chat are actually, like, know more math than me, and I'm like, nah, you guys don't want to stick around and watch me do this basic stuff that you guys have done years ago. I think you will. I had zero hope. I was going to get accepted, and I got in somehow. I wouldn't have taken myself if I was in the admissions committee. I doubt that though, because for me, I'm already 34, so like for me, I just like look at my interest in math and physics as sort of like my own life pursuit. Like, it would be nice if I can like learn up to the point where it's like I know a little bit, like probably like 0.000000001% of what a grad student knows, but you know, like that's practically something that I think I will be like kind of aiming for. Because the thing of it is that for me, it's like, I know I wouldn't be able to do grad school because they just pressure you so much. And not only that, like going to grad school, unfortunately, you can get a PhD or a master's, but that doesn't guarantee that you're going to be able to work in the field, which is unfortunate, because I think like people with PhDs, like they work so hard to get into the research, and like, I mean, they're on their research, and like, you know, and it's unfortunate, but they can't be given like professorship positions. And you know, it's like, I don't know, like I feel like PhD students, like, or PhD graduates, like they would be able to do so much with like the knowledge they know. But it's unfortunate that they won't be able to get the positions that keep them within their field. But, you know, like, life is filled with so many curveballs. I mean, if you have a PhD and you start your own business and you become successful in that business, I would say, yay. Like, that's practically like the bonus. The robotics problem needs funding. Yeah, especially AI too. Like, all the like hype tech stuff is always gonna need funding. I feel bad for like people that are scientists too, because like they have to go to like committees to actually like, unfortunately, beg for funding for their research. And I kind of find it like very, very ridiculous sometimes, because it kind of feels as like, because you also have to be able to talk to the public and basically say like, I'm going to talk to these non-scientists that don't understand my work, so I have to present this research in a way that they can't understand, and I got to show it to them that it's important over other people. Which I think, like, with science, like, everything is important, even if it's, like, seems like the most minuscule. Because you will learn something either way. I mean, like, if I'm, like, I don't want to, like, overstep, because, like, I know some of you guys are grad students, and some of you guys already have your degrees. So, like, if I'm overstepping, let me know, because, like, I obviously don't have a bachelor's or like a master's or a PhD in any of the STEM fields, so I don't want to overstep, but It's just my way of basically trying to be compassionate towards like the struggles of STEM grad students, because I feel for them the most, because they do a lot of research and they sometimes put their health at risk, and I kind of wish that they didn't do that. Let me see what you guys typed up. There are a lot more PhDs than there are positions, and a lot of positions are adjunct positions that lead nowhere. Yeah, that's the one thing I don't like. It's like, it should lead somewhere. Like, I mean, some adjunct positions, like, don't get me wrong, they can lead to an opportunity, but I feel as if like a majority of them don't, and I just feel like, why? If you stay below a minimum wage for a while to keep yourself in the game, maybe an opportunity will present itself. Yeah, that's the thing, because a lot of people have done that path, and like they get so frustrated because it's like, when is my time gonna come? And they're kind of expecting results from just doing a strategy that eventually they might question themselves, and then they say like, oh, it's not working, you know? Because like, people can like do so much in so little time, you know? I remember in my country, prof said we take people for undergrad, not how much they know, but if they can learn to self-study and motivate. I don't know how much of a leap knowledge there needs to be for this to be untrue. But I think to a large extent this is true. Yeah, because like, I think for me it's like, I like self-teaching. I love learning, like self-learning, because when you get older you're gonna need it. You're gonna need to learn, especially like when you get older, because you're out of school and no one's telling you to learn. And you know, for me it's like, I've gotten into the subject because of like my own curiosity and my interest. Actually, like, I got into math and physics because after I learned the I say crazy stuff, but like the interesting stuff within theoretical physics and in mathematics, like you know, like Mobius strips and like, you know, a torus and topology, as well as well, I did catch the string theory bug, but I like it for the mathematical like curiosity of it. Like, I like physics because it provides a mathematical like framework of how things work, but I think I would look at it more through the eyes of a mathematician. Like, basically like, ooh, there's a mathematical formula, let's try to see if we can break it. Let's see if we can break it and see like what happens if we do these type of parameters. Yeah, and like, when I started learning how like interesting the subjects were, I really wanted to create a story where it revolved around like how, like, the magic system that I wanted to create revolved around like using physics/math formulas to manipulate the world around the main characters, like involving space and time and stuff. But I realized that I didn't know enough, I guess, like mathematical/physical knowledge to actually be able to implement a story of that intricacy. I still have it in the back of my head, it's just that I haven't written it because like, I still don't have the mathematical maturity. Hogwarts Legacy? Well, I do have the game, I haven't played it yet. But yeah, the story is sort of like this. I think of the story as sort of like this. Like, the characters do, like, one of the characters does use a magic wand, but it's technically a scientific instrument. Do you do a fair bit of writing otherwise? I sometimes try to write the first chapter, but whenever I write the first chapter, I sometimes like write too long on a particular moment and I end up scrapping it. So I have to rewrite everything all over again. So yeah, like, I have a lot of notebooks that have a lot of like bad versions of chapter 1, but I haven't been writing recently though. It's just all in my head mainly because I lack like mathematical knowledge and physics knowledge, like, I guess for like something that's sort of like, I guess on the undergrad level, I have to I have to like really think about how the physics/math fights are gonna happen. Like, because like, I want the fights to like, if you guys are familiar with anime, right? I really like my favorite anime is Yu-Gi-Oh! And I imagine that every single fight in my story is like Yu-Gi-Oh, where it's like the main characters are facing a big conflict, and then the only way they can do it is just by using math and physics to counter it. And of course, like, since I'm not an undergrad in physics or mathematics or both, I have to study the subjects in order to actually create like problems for the main characters, and then also create solutions for those set problems. Because I imagine them basically, like, the main characters create like equations in the air, in like midair, and like that's their way of casting spells, and then they would create a physical scenario where it's like the math actually helps manipulate the situation where the problem actually like gets turned back on the enemy that they're facing, if that makes sense. But of course I have to think about things like the violation of like not violating the conservation of energy and all the other stuff that makes our physical world the physical world. Okay, before I get back to like our next study session, I will be right back, guys. I'm just gonna use the restroom for a quick second. Okay guys, I'm back. Alright, I think it's time to actually get back to our study session. I know I was yammering a lot there, so apologies if I yammer too long. It's like, we want to get back to the math, and I'm like, okay, we'll get back to the math now. Study timer is on, and now we're in math mode. Let's go. Let's go. Let's drag this down here, and hopefully I got that right. I think I got it right, but sometimes you don't want to assume too much. Okay, what is the next one? Okay, let's go. Okay, B, we have, so these are first order linear, so I think I'm familiar with these. X of t equals 1, x of 1 is equal to 0. Okay. I think this is similar. Yeah, this is similar to the integrating factor again. Yeah, it looks like it. Yeah, the way it's organized. So, integrating factor, it is. So it's negative, so I guess we're gonna have to put a negative in here. So let's just move the -2 outside. We don't really need it. And this is... Aha! I see where you're working at. So, to that we... Great. Now, we gotta move you... No, oops. Not down there. Wrong place. Right here, -2, and then that will result in -2 here, which is okay. Okay, so now we multiply this. Let's just turn this into dx dt, make it a little easier on the eyes. Do that. Then times this. We'll just leave it at x. We don't have to put a t right now. And then dt dx. Okay, let me just drag this up like that. And let's see if it matches the product rule. So we have x, so these two, so it's going to become 2 over 3. Like that. Like this. Lovely. Okay. So, yeah, so and then bring up to 2, and yeah, that looks like it's about right. Yeah, because it's a negative. Okay, cool. So that looks like it matches. So that is the product rule of these two things. So, oh, whoops, no, I wrote the wrong thing. Ooh, I want the eraser. Okay, T over here. Actually, I'm curious, what are you guys are working on right now for yourselves? Or if you're just enjoying like what food you brought in, because I know some people were making food. Okay, so now we can just, now we have to integrate. So we'll do the first side first. We'll just write this down here, x here. And now I think we can put the xt back in here. So now we have minus 2e, and then we'll just plus 1 here, t, and then, which is negative 1, and negative 1, thus making it negative. Yeah. Very good, very good. Now we can just write this down here. So now it's negative 1 over t. Oops, that looked like a tau for a second. And plus c. So now we just multiply by t squared. So t squared times so those two cancel, and then we're left with negative t, and then plus t times c. I mean, granted we can just write it like this. Let's take the negative t out, and then we're left with c. Well, actually it would be negative c, right? Yeah, it would be negative c. So it would be 1 minus c. Yeah, because this one's negative, so that would be 1, and then... Oh, hello, weighty editor? Hopefully I pronounced your name right. Weighty editor. Oh, thanks for the follow, weighty editor. Let me know if I'm mispronouncing your name. I want to make sure that I pronounce it correctly. I just took off my model because I realized my model was like fidgeting out. You're French? Welcome. Unfortunately, I don't know how to speak French, so I'm guessing English is your second language, so I hope you don't mind me speaking English. What brings you to the Math Spellbook channel, Witty Editor? Welcome. What's the best part of your day so far? Calc 3, how old are you? I am 34, so, not really. It's like we're trying to do like partial differential equations, but the first part of the book, they teach you differential equations, so basically we're just trying to learn like the differential equations that we should know for partial differential equations. So I think we got the answer. So I think this is the answer right here. Love of math. Nice, nice, nice. But you're more than welcome to chill with us and study with us. And if you don't mind me talking while I'm actually doing math problems, that's fine. If you just want to study and have me in the background working math problems, you're more than free to mute me if you like. Hey, Sasha, how's it going? I thought I wasn't going to see you, like in the stream, because I haven't seen you in a while. But I'm guessing it's basically you're busy too. So I want to thank you for teaching me about the heat equation, the last time. That was actually a very insightful, I guess lesson about that. So I really appreciate that. Calc 3 is the most non-math calculus. Therefore, it was my least favorite. Really. Like, the thing of it is that, like, I think with Calc 3, I like learning about vectors. The problem is that I still haven't mastered, like, the distance between a plane and a line, or a plane to a plane. Because I know those problems exist, and whenever I do those problems, those feel the most boring to me. Like, actually figuring out the distance between two planes, or the distance between a line and a plane, or, like, the intersection of a plane and a line. Like those problems, I felt like I was kind of like I don't want to say they were boring, it's just that they felt kind of tedious to me. Like, I have to relearn those. Good, I'm doing my dishes. Oh, nice. Yes, those problems are boring, very computational, finite subcases. That's kind of why I didn't like it. Yeah, the reason why I would want to learn Calc 3 is, like, I don't know Stokes theorem. I actually would like to learn Stokes theorem, because that theorem seems fun. I mean, not fun, but it sounds intriguing, because I know nothing about it. But at the same time, like, I heard that Stokes' theorem goes into higher mathematics, so that's why I'm kind of intrigued by it. Because, like, for me, it's like, I heard that Stokes' theorem is also a more generalized version of Green's theorem. And, like, when I heard that Green's theorem is sort of like I think a two-dimensional version of Stokes' theorem, I was like, yeah, when you think about it, you really do learn, you do need to learn Green's theorem, but at the same time, it's like one of those back knowledge things where when you get tired into higher subjects, you realize that, oh no, I might as well just remember Stokes' theorem. Or, like, just master Stokes' theorem, at least. I don't know. That's just me, though, but I could be wrong, because obviously, like I said, I don't have a high degree in... I don't have a degree at all in math or physics, so, like, if anyone wishes to, like, say, like, I'm wrong here, please let me know, because I don't want to be saying, like, stuff that is not true, you know? Okay, so we got sine... Okay, so we're gonna have to manipulate some stuff. Yeah, we're gonna have to divide sine on everything. Oh, don't tell me I have to do cotangent. Sine. Oh, do I have to know the trig identities? I probably do. Let's see. Now that you made me curious, I'm wondering if Stokes' theorem applies to manifolds and differential geometry. I saw a video where they were talking about Stokes' theorem, and they said that Stokes' theorem is sort of like because like I remember the video. The video was talking about how people thought that the opposite of differentiation is integration, but according to the video, they said that no, actually the opposite of differentiation is like Stokes' theorem, involved with Stokes' theorem, or something like that. I have to rewatch the video again. I think the YouTuber's name was it Afflet? I don't remember. Dang. I feel like I have to know a trig identity for this. Sine of 2x. Sine of 2x. I feel like that's a trig identity, but I don't remember. Cool, I didn't know that. Well, I don't remember exactly the video. Actually, let me see, because I'll probably post it. I think it was what? Let me see if it pops up. Oh, here we go. Yeah, Stokes' theorem on manifolds. I'll just take the link and I'll put it in the chat so you can check it out for yourself. Yeah, it was a pretty interesting video, actually. It's only 6 minutes, so I was like, oh wow. So that's why I got curious about Stokes' theorem. But I didn't really continue on with Calc 3. Maybe I should do Calc 3 for stream, so that way we can learn it together, actually. Well, I would learn it. You guys probably will be like, oh no, he doesn't understand this part. We gotta help him. Alright, so... Alright. Sine of 2x. I feel like that's a trig identity somewhere. But is it like 2 times sine and cosine? I don't want to look it up though. Because I think that's from pre-calc. But I don't remember. This is why I love math teachers that are sympathetic to students. They basically like, oh, you don't remember? It's like, here's the formula. It's like, oh yeah, I remember that. Because that actually helps, for me, that helps me remember it much easier. Because like when a teacher's like, oh, that's okay, like if you don't remember. Like I'll write it down for you. And then they write it down and then I remember it much better. Like with teachers that basically expect you to remember everything that you've learned and like they don't re-review it or anything, like those teachers I get very intimidated by. Because I'm like, I don't remember this, and I'm like, oh my goodness, what's wrong with me? Yeah, I'm gonna have to look it up. Shoot. Well, if I look it up, it probably will make it easier for me to remember that for the next time, because I know it's a trig identity, I think. Yeah, I was right. Okay, yeah, it is 2 times sine and cosine. Yeah, because I know the sine is gonna vanish. Because I'm like, that is a problem that's meant to be a clever problem. I am afraid about this factor here, because we're going to do the integrating factor next, and with the trig identities, when it comes to integration, I sometimes forget, especially the ones that don't come up that often, like cotangent and secant. Like those are the ones. Well, secant I think I remember better because you see identities that use them a lot in calculus, but when it comes to like cotangent and what's the one with the C? I forgot what they call that one. Shoot. Let's see. Okay, the integrating factor to negative. I am not going to change that. Like, I'm not going to rewrite it as like the other trig identity, because that's going to like totally mess me in the brain. So I think we're going to have to use U substitution. So we want to, so it's going to be like du. So we have sine, and then basically we'll carry the bottom. So I think sine is going to be the one that's on the bottom here. And so we change that to cosine of x. Yeah, so we change that, and then dx becomes du of cosine of x. Yeah, so then we'll just move the negative sign in front, and then we're gonna cross that out and make that du, and then that's gonna be oops, that's gonna be negative u, but then that's turns into this. That is sine of x, and then because that is so, it'd be 1 over sine of x. It's kind of funny that in differential geometry we don't talk about vector calculus that much. We rather prefer working with differential form. The reason is that stuffs like gradient, curl, divergent, Laplace, etc. depends on the Romanian metric, which is extra data for your manifold. Oh, okay. Not even an undergrad differential geometry. Yeah. Okay, so let's continue on. So we know the integrating factor. So multiply this minus cosine sine x. And yeah, we still have a cosine, 2 times cosine here, so 2 times cosine x, and then we just basically just multiply that by 1. So we practically have like 2 times tangent of x, and so does this work with the product rule? Yeah, because then, yeah, well, that's integrating. What am I thinking? Differentiating. We had a course on differential form before the differential geometric class, but usually for undergrad differential geometry, people worked with embedding surfaces on R3. In that case, that's much easier to define a metric on your surface, just as the restriction of the Euclidean metric on your surface. Oh, okay. Yeah, I actually have a book on differential forms. It's a very small, thin book, actually. I think it's like one of those books that like someone who knows mathematics, they felt like, oh, I want to make a book that's like easy for people to understand differential forms. I don't think it's meant to be a grad book. I think it was meant to be like a book that's accessible to everybody. Shoot. Did I do this right? Because then we got cosine, sine, yeah, and that negative goes on top here, thereby making it negative sine. I mean, like sine to the -1, which equates to that. I mean, that looks right. Actually, let's see if what happens if you take the derivative, so that way I can remind myself. So if you take the derivative of sine of x, well, technically that's so you take dy. Well then, yeah, if you turn, let's say if you turn sine into this instead. Oh, wait a minute. Oh, okay, yeah, it does work. Now I see it. Okay, now I see it. Okay, I thought I was like confusing myself for a second. Yeah, that does work. That does work. Because then, yeah, because like the way it's structured would look like this. Okay. I bet you guys are like, it's obviously right there. It's obviously right there. It's like, does he see it? Let's see. So now we can basically say that this is sine of x, the product rule of this, oops, and then equals tan of x. So then we can just integrate both sides like so, and we're left with sine x. And then we have to integrate this fun part here, which I don't think is too much of a problem. I've done it so many times. So instead of just trying to remember it, do sine of x, cosine of x, and I believe it's going to be like the natural log, the negative natural log of cosine. So let's do that now. So it's cosine of x du will equal to, yeah, negative sine of x. Yeah, so therefore we're given -2, and then 1 over, yeah, du, thereby giving us the natural log of cosine of x plus c. And then we're going to have to multiply sine of x. We are on a roll. Nice. So sine of x times 2 natural log cosine. And I think that's the answer. It looks about right. Let's see. Using Lee, someone not learning anything in Calc 3, I think my naive approach is double-edged. I mean, everyone learns different ways, to be honest. You know, like even though I don't know like all the details of Calc 3, like I did find a book that taught me about like gradients, divergence, curl, and the Laplacian. So I know what those are. And I did learn like multiple integrals through a video. Like you have to do the inside integral first, and then you work your way out on the outside. I mean, that's the basic technique, and as long as you learn like little by little, I think that's fine. I mean, like if anyone can pick up a textbook, read the textbook through, and they know everything section by section, then, you know, I give them credit for that, but I can't do that. I also thought that there were things that were easy, but my professor told me nothing is easy. I gave a second thought about it and realized that I was just being pedantic. Everything is hard, but the catch is depth of the topic and ideas. Yeah, I mean, the thing of it is that like there's always a way to figure something out, but the thing of it is that you have to be like you have to reassure yourself that you don't know all the answers, but at the same time you also have to give yourself a little compassion where it's like, we will find this answer. It's just that I have to think differently. And if you can't think of like what is the solution or the technique, that's when you ask for help, you know. I have to admit that I'm wrong like a lot of the time, especially when I'm doing problems, because I think I probably know the natural flow of the solution, but at the same time, like, I have to actually question myself on whether or not the solution makes sense or not. I bet you that, like, some of my VODs, like, I bet you there were times when I did problems and I thought they were correct, but they were just totally wrong. But I thought they were right, you know? That stuff happens. Okay, so what do we got here? I guess they just want us to practice the integrating factor the whole time. Like, what is the next question, actually? Oh, it's a word problem. So, oh yeah, they also gave us a parameter. I forgot about that. So we're not finished with this question yet, because they gave us a parameter to figure out what the constant is. So x plus 1 equals 0. So which problem was? I think I was working on C. Yeah, I was working. This is C. What was C's parameter? C was, oh, okay. So first let's just do C and we'll work our way back up. Because I forgot there were parameters there and I didn't focus on the parameters. I should have focused on the parameters. So C is pi over 2 is equal to 0. Okay. So with our final solution, oh, nope. We had so if we have pi is so was it pi over 2? Yeah, pi over 2. So it's pi over 2. So if it's pi over 2, then that means this is, so sine is going to be 1 and cosine is going to be 0. So then if it's 0, then that would mean, wait, hold on a minute. Let's see, pi over 2. No. Yo, yeah, because then that's where it's like it. Huh. So the natural log of 0. No, that can't be right. Now I'm forgetting basic algebra. Least smooth manifold is good for a beginner, but it lacks some direction for someone who is new to the field. I don't think natural log of 0. Can that happen? I'm probably like asking a really stupid question. No, that can't happen. Okay, this is tricky. Unless I did something wrong here. Because it's supposed to be pi over 2. Pi over 2 for sine is 1. And for cosine it's 0. But it's the natural log. So we have a bit of a contradiction here. Unless I missed something. Okay, time to check what I did wrong. More likely I did something wrong here. We got the trig identity. Did I make the wrong assumption here? Can you recommend another book? The professor is skipping a lot of stuff. It's the third week and we are doing free action now. Yeah, that's a good question to ask Sascha. Basically, what are your personal goals for the course? Did I make the wrong assumption? No, it seems like it seems it would match. Because everything seems to line up fine. Let's see, tangent, sine. Yeah, I did get the identity right for that, so. Yeah, and that would turn into a negative sign. I have this book from Calculus 2. I was recommended. We'll start studying it every weekend. Oh, okay. Interesting. What is homology? I never heard of that. I feel like I did everything right. It's just that it says the natural log of 0, and I'm like, that can't happen. So what did I get off here? Because I feel like I did everything right here. Yeah, you divide that, and then you do the... Did I use the wrong trig identity? Huh. Let's see. Let me see if the parameters are right. So yeah, because like it's, yeah, it says y, so x has to be like, it has to be pi over 2. Huh. I mean, I feel like we got the equation right. It's just that, why is it that yeah, because cosine is on the bottom, and then we cross that out and get us the negative. But why? I feel like I didn't make a mistake here. Did I make the wrong assumption? Let's see. Yeah, we wrote the problem correctly there. And yeah, so yeah, that's right. And then we wrote it here, and then we crossed out the signs on the bottom, so it would be cosine. Oh, maybe we made the wrong assumption here, because I think I see my mistake here. Let's see, cosine, sine. Oh, I think I see it. Okay, I think I see my mistake here. It's not this, because it's cosine over sine. I wrote the wrong thing, so it's supposed to. There we go. That's the reason why I was wrong. Okay. So now we have to erase this. Oops. So erase this part. So let's make this easier. Bring this down here. That's what I was wrong. That was wrong. That was why I was wrong. Okay, so I think we can just erase this part here. Delete that. Bring this down here. And then nope. Okay, there we go. Now we'll just go back up. So let's just rewrite this again. I wrote the wrong trig identity. That's the reason. So this time, so u is going to be sine, and then du is going to be cosine. Yeah, that's why. Okay, so that makes it much clearer. Equals x. So yeah, then those cross out, and then we're left with du. There we go. That makes more sense. Yeah, because then we won't get a negative, we're just gonna get a positive, so this will make it sine. There we go. And then we have sine of x. More likely it's something that I did wrong. Because I'm like, that doesn't make sense. Okay, so now we got the actual thing that we're supposed to. Okay, so now the parameter is 2. Okay, so this is gonna equal, so pi 2 is equal to 0, right? So we're gonna get this is equal to 1. Yeah, so this one is also equal to 1. And then plus c. So then we get 1 times, well, we don't really need it, so it's going to be equated to, so 2 plus c equals 0. So that means c is negative 2. So the whole equation itself is equal to sine of x sine of x minus 2. And we got it. Okay, so that was better. Chromology, this is a way to attach some algebraic object to some geometric space in order to extract the invariant or property about our object. This is very general. You have a lot of okay. Thank you for explaining that to me, Sascha. I appreciate that. Okay, so we managed to get that problem right. Cool. So now let's take a look at the parameters that we're missing for here. So this is b, so b is equal to 1 is equal to 0. So if we have x equals, well, t is equal to 1, so that means it's going to equal negative, and 1 minus c, that will turn this into c minus 1, and that's also equal to 0, so that means that c is equal to 1. Meaning that this then that means the whole equation is equal to 0. It literally just equals to 0. Well, technically, just t minus t actually. Just means minus t. Interesting. Wasn't expecting that. Okay, I think A also has a parameter. So A is y is equal to 0 equals 1. So it's equal to 1, so this is 1. And if we put 0, that would make this 1 plus c. And then we get e for 2. So I guess we have to multiply. Drag this on this side here. Yeah, I know it's break time, but we are so close to finishing this actually. So then c is equal to, wow, that's a doozy. So that means y of x is equal to 1 over 3 plus, sheesh. Talk about like an extreme parameter there. Okay, there we go. Not bad, not bad. We managed to get through like one problem, and well, technically we would probably consider it like 3 problems, because we just have like another problem with multiple parts, and we'll probably work on this like I'll probably work on this on my free time. Next week I don't know what we'll be working on. Maybe we'll continue on with this book, but who knows? Who knows? I will turn on my model back up. So I guess you guys are just talking about differential geometry in the chat. I'm glad like my stream was able to have you be productive and asking on very, very awesome questions about like a lot of like high level stuff. So I think that will do it all for today's stream. I just want to catch up on chat and see what you guys are like talking about. Let's see. I read that. In my album of I have only the collection of some political and hope. Well, I wish you luck with that. Surino. Actually, do you mind if I ask, Surino, do you mind if I ask where you're from? If you don't want to reveal that, that's fine. I'm just actually curious. I'm usually curious on where you guys are from around the world. The only homological algebra that I know is... Explain to me what are projective revolutions. Oh. I mean, at least you're at the level where you understand that. I mean, I don't think I'm anywhere near that level. Like, the only thing I know is, like Calc 1. Try to remember Calc 2. Some stuff from Calc 3. A little bit of differential equations. And, like... That's practically it for me. And a little bit of linear algebra. Like a tiny bit, not that much. I mean, the things that you guys are talking about, it seems like you guys are like high up. South America? No, it's okay. It's okay. That's fine. I'm just glad you're able to like ask for help and like, you know, exchange ideas with Sascha right here. Keep learning linear algebra and you'll be able to understand that soon. Yeah, I think the thing that I'm lacking with linear algebra is linear transforms. I think distances between planes and lines, because I actually went back to my old linear algebra book and I realized that I stopped at the point where they were talking about the parameterization formula for a line and the parameterization formula for a plane. And I think the distances between like planes and the distances between a line and a plane, or the intersection points, I think those are that's where I stopped at. I did read briefly on vector spaces, although I haven't done problems involving vector spaces yet. So I got to do that. Linear, like I did do linear algebra in like when I went back to school. I did take an online course on it, but the last couple parts I felt like I was just looking up answers. I wasn't really learning because I was just trying to pass a test and get the homework done. So, and online homework is pretty brutal. Like, I remember back in the day when I went to school, I just wrote my assignments. I didn't have to, like, type it out. But when you type it out, it's a whole nother animal. Yeah, I barely remember, like, linear transforms and, eigenvalues and eigenvectors. But yeah, I will take that advice. Yeah, I will learn linear algebra. Like, I'll probably do that during the next couple of days. I also don't know calculus, but when I went back to the subjects, the surface area comes... Yeah, because like when with Calc 2, I don't remember the line integral. I know it's like the square root of something, but I barely remember it. And I barely remember the washer and the disk method. Oh no, I think the disk method is the washer method, right? Yeah, like I forgot that method of integration. I would encourage you to learn general theory of vector spaces over a field. Oh, okay. So, like, for linear algebra, like, because I do get bogged down by the details, so you would say I would have to focus on vector spaces, I'm guessing linear transforms, and eigenvectors and eigenvalues, right? Is that what you're saying, Sascha? Because actually, like, I think the reason why I make my streams is so that you guys can actually kind of guide me into making the most efficient study method. Yeah, this is a good start. Okay. Yeah, because I think, like, if I were to create, like, a book about math and physics, like, I mean, besides my story, I think I would probably create a guide on like how to actually learn math and physics with a little bit of problems. like you don't have to, like, even though there's a long prerequisite of math, we're gonna break it down so you know you have to learn the math that's very important for the subject, for physics in general. So it's like you don't have to like learn this whole textbook of knowledge of one subject just to get to the next subject. I would learn basic algebra modules first, then linear algebra, then play with matrices, then are my favorite books, or do it in foot, which is least recommended. You should aim to prove the diagonal theorem for symmetric matrices of real numbers. Okay. So wait, are you recommending like computational linear algebra or proof-based linear algebra, Sascha? I would not recommend learning module theory before vector space. Proof-based? Oh, okay, yeah, because like I'm talking about like I have to relearn like computational linear algebra first before I do proofs. Like I haven't fully like learned real analysis yet. So I don't think like with proof-based linear algebra, I don't think I'm ready for that yet. Yes, diagonalization is ultra important also for spectral theorem, even for operators. Just the surface, not too much in depth. I see. I mean, you guys are so knowledgeable. I'm like, wow. Like, you guys are just like at a higher level. I guess like it's that old saying from like the Mask of Zorro, what Anthony Hitchens said. It's like when the student is ready, the master will appear. and I look at you guys, it's just all masters. You guys seem to like know a lot in depth. I'm just barely getting by with the computational stuff. I mean, which is good because like I guess like for me, I don't mind feeling like I'm the one that doesn't know that much in the room. But that shows that I have a lot to like learn and climb up to. But like, I thank you guys for actually providing this amount of knowledge in my chat. It really means a lot. And if you're tuning in for the first time and you like math and physics and you're enjoying, I guess, like a guy just doing simple math problems while you like work or just be productive on your end, give my channel a follow if you like. It really helps out my channel, and also it keeps inspiring me to continue to do these streams because it allows me to actually build up my own confidence within the subject of mathematics and physics. Mainly, we're just focusing on mathematics, but at the same time, it's like I do a little bit of physics so I can actually learn the math of like what's involved within the subject itself. Physics in general, I mean, because I actually like the physics because of its mathematical like foundation. I'm sure you'll be fine in proof-based linear algebra. That's usually the first class undergrad take in their first year. I thought it was computational linear algebra though. Because like, I mean, the linear algebra course that I took, like, I just basically had to compute everything. I didn't have to prove any of the ideas though. Plus, I haven't fully mastered, like, proof by contradiction, proof by contrapositive, and all that other stuff. Because I thought, like, the first class that most undergrads get exposed to is real analysis for, like, proof writing. And I apologize if it sounds like I have something in my mouth. I do. I have a cough drop in there. Usually when I talk to you guys, I, like, take a cough drop when I stream. But for all those that actually dropped a follow today, thank you very much. I really, really appreciate it. It basically feels like we're like making our own little like professor like scholar like institute, you know, because all you guys are so knowledgeable. I just didn't know that math was this popular like on Twitch. And I hope you guys like really like are really enjoying like the math content, because for me it's like whenever I talk to you guys, I feel like the math that I'm doing on stream is mostly so basic that like you guys might lose interest because it's like, oh, this This is so basic for me. I know how to solve this in my sleep. I would argue it is easier to learn proof writing in linear algebra than learning proof in real analysis. Really? Why is that? Why is that though? Is it because like linear algebra, like the ideas behind it is like I don't know how to describe it. I mean, like when you do computational linear algebra, it does feel like it's like an extension of algebra in some way. Because you don't have to worry about learning calculus unless like it's a calculus based like course. Well, it would seem that I sound knowledgeable, but that's because I hate details. I like to fly and see everything from the sky. Yeah, I'm the same way. Surino. I have only landed for a particular subject, some calc, linear algebra. This is why problem solving is my weakest part. Yeah, that's the same with me. I like reading a lot, especially when it's like mathematical ideas. I like reading it, but I don't do well on the problem solving because it shows that I don't fully understand like what the definitions are telling me. You know, it's like, I guess for me, it's sort of like, I know I have to learn the basics. And, you know, there are times when I debate whether I should do proofs on stream, or I should do computational math. And, like, for me, it's like, I know I have to learn both. Like, the reason why I'm doing partial differential equations is because I want to be able to learn higher maths for physics. But I like the books that allow you to skip like different classes and will kind of like skip over certain details that you know that you don't really need for the subject. Which is why I really like the book that I'm using. Partial Differential Equations by Bleecker. So don't feel bad that you feel weak about problem solving, because I know I'm weak at problem solving too, actually. In linear algebra, you have a lot of easy proof for beginners. Oh, okay. In real analysis, you have to define the real numbers, which is not very intuitive process the first time you see it. Oh, okay. Maybe I'll try it. I'll try proof-based linear algebra. I'll probably give that a try. So is the book Linear Algebra Done Right? Is that a proof-based book for linear algebra? Or is that a computational book for linear algebra? Because I think it's a proof-based book, isn't it? I don't know if you're familiar with that book, Sasha. I think we were talking about it the last time we were chatting. Yes, that's a proof-based book? Okay. I'll probably like try to do some problems from that then. Not well read. Well, not reading. It would be the first layer. I go to the second layer where I actually learn the details, but not focus on it. Just the idea. Yeah, that's true. Yeah, I'm the same. I like to look at from the sky, the bird's eye view, but then you lose the details and you just don't know what is it that you need to implement. I will have to look. My main references in linear algebra are in French. Oh, okay, gotcha. Asin goes more in depth if you're interested specifically for the last part. Oh, okay, gotcha. Well, I think that will be all for today, guys. Thank you for tuning in. For anyone that's still in the chat, if you're lurking, thank you for lurking. Like I said before, like if you like math or physics, be sure to give my channel a follow. And also, if you would like to join our Discord server, then you're more than happy to join our Discord server. Kind of grow our little math spellbook library Discord server, you know, so that we can talk about awesome ideas and maybe exchange some ideas that some of our members that are grad students are trying to like learn for their try to research for their thesis and stuff. And also, if you just tuning into the VOD and you miss like part of it, you can subscribe to my YouTube channel. I will be uploading this VOD onto YouTube, so for the parts that you missed, you'll be able to catch those stuff up there. And I will also be streaming tonight on my other channel, my Uncle Talks channel. So if you're interested in watching me play video games while chatting with you guys, you can also follow me on my Uncle Talks channel. Okay, So I think that will be it for today, guys. I will be back next week on this channel to like probably do more math and physics. So I hope you guys will be looking forward to that, and hopefully you guys will also be able to work on your own projects during that time with me. Whatever it be, maybe whether it be math, physics, or whether it be art or anything you have to do through your own computer, or or your tablet or whatever. So take care, guys. I will see you next week on this channel. So always remember, everyone is precious. You guys are just as precious as everyone else, and we will see you next week. So take care, guys. Bye bye.